Hello everyone. In this video we're going to go through the quadratic equations. This is for a college algebra course. So what is a quadratic equation? It is an equation that includes the square of the variable x. So it's ax squared plus bx plus c equals 0 in the general form. So you have constants in front of x squared and x and other constants as well. That's all like combined with addition, and that's the quadratic equation. Now we have multiple ways to solve quadratic equations. The first one is factoring. Then you can just say squared property, completing the square, and quadratic formula. I'm sure you heard about quadratic formula and factoring, and all the others are straightforward as well. Now the factoring really works when you have a product that's equal to 0. I mean, we know from basic algebra that if you have a product that's equal to 0, then one of those expressions need to be 0. Like, for example, look at these examples. In the first one, of course, you need to set one side equal to 0. And you can subtract 14 from both sides, and that 14s will cancel. You can't combine those. So from here I got x squared minus 5x minus 14 equals 0. Now here's a good rule, easy rule. You try, since this is a monic quadratic equation, like x squared is coefficient simply 1, you can look for two factors. It's kind of like you're trying to, when it's factoring, you try to write it in the form, since this is 1, it will be x here and then kind of another x in here, so equals 0. And you know FOIL, you distribute each term to the other one in the second factor, and whenever you combine, you want to get x squared minus 5x minus 14. So how that works is, if you find two factors of 14 whose sum is the middle term, then that makes it work in these type of problems. Now find two factors of, let me simply erase this one for now. Let's say we look for something like x here and then another x here. See, we will get simply x squared. So I'm looking for two factors of negative 14, and the sum I want to be negative 5. So as you see, that's going to be negative 7 and 2. If you add them, you will get negative 5, and their product is negative 14. So it will be x minus 7 and x plus 2. Probably you know about factoring a little bit. But on this case, like, you can use FOIL, distribute the terms. I have x squared, negative 7x plus 2x, which is negative 5x, and negative 14. So that works. You can check it all the time. So from here, we just say x minus 7 equals 0, or x plus 2 equals 0. So x should be 7, or x should be negative 2. So these are our solutions. And sometimes we just write it as a solution set. So we just write it as a solution set. Sometimes SS, we just write it as 7 comma negative 2. So these are the solutions to this problem. Now the next problem, what if we have an equation? I mean, I can just simply take this a bit down, but what if you have an equation in which the square term, t squared, does not have the factor 1, it's other than 1. Now the point is this: you look for factors of 12t squared. So you're going to write it again in the same form, right? And then you're going to use the FOIL. So I have 12t squared, and I have the last term negative 1. Now 12t squared, I always use those positive because that's like a positive term, and you can always make it positive. If it's negative, you can multiply everything by negative 1. So the factors is like, for example, I can write 12t and then t to get t squared. For negative 1, you have only factors negative 1 and 1, nothing else. Now the point is that if you multiply, because you're going to use FOIL. FOIL means you simply cross multiply each term by the other term on the right side. You will not be able to get negative t, because 12t multiplied by these two and t multiplied by the other one, if you combine, you can get, for example, maybe 11t You can maybe get like something like negative 11t, but you will never be able to get negative 1t. So this one does not work this way. Now you can see 12t squared. You can also write this as 4t and 3t. Well, that works, because if you multiply 4t by negative 1, it will be negative 4t, and 1 by 3t, you will get negative 4t plus 3t, which will give you, yes, negative t. So 4t needs to be multiplied by negative 1, and 3t needs to be multiplied by 1. So I got this factoring as 4t plus 1 times 3t minus 1. As you see now, I got 12t squared, I got negative 4t plus 3t, which will make negative t, and negative 1, which will make negative 1. So that really works. So this is the way when you factor these type of quadratic equations. So from here I got 4t equals negative 1, so that's going to be 0. So t needs to be negative 1 over 4. That's one solution. Or I got 3t equals 1, and then t will be simply 1 over 3. So these are the two solutions that we get. You can write the solution set as negative 1 over 4 comma 1 over 3. Now these are the problems about factoring. I have one more problem. So I simply want you to try. So can you, like, it will be good if you can pause the video and try this problem yourself. The problem at the bottom now, you can see, try this problem yourself for a couple of minutes, and then yeah, then we'll come back. Now here's a solution for that problem. Just don't forget, you can FOIL this x and make it a quadratic equation and set one side equal to 0 and then factor. This is the way for this problem. You can check that. Now the next one is the square root property. It's really, I mean, it's a simple rule that if you have x squared equals k, then x will be minus plus square root of k. Now like for example, x squared equals 4, then you get x equals minus plus square root of, so minus plus square root of 4, which is going to be minus plus 2, something like that. Or it can be square root as well. So now the thing is, we may have these type of problems. It's simple, and you don't have the middle term, you don't have the x term, you only have the x squared term. Like, look at this problem. It says if a metal ball is dropped 80 feet from a water tower, its height is after t seconds is given by this formula, 80 minus 16t squared, and it says how long it takes the ball to hit the ground. So the hitting the ground means the height will be simply 0. So you need to set this set this h function equal to 0. So I have 80 minus 16 t squared equals 0. Now you can move this negative 16, or you can, I mean, it doesn't matter, you can subtract 80 from both sides. So these two will cancel. So I have negative 16 t squared equals negative 80. Then I can divide both sides by negative 16. Okay, so these two will cancel, and I have t squared equals 5. So t needs to be, let me write it separately, negative square root of 5 or square root of 5. So this negative square root of 5 does not work because you know t needs to be positive. So the ball hits the ground after square root of 5 seconds. Yeah, that looks really weird, but you can use a calculator to convert it into a decimal, which will be simply 2.24 seconds. So that's how you solve that problem. See, that uses the square root property. T squared equals 5 implies t equals minus plus square root of 5. So I hope this example is clear. So now we're in the completing the square method. So the completing the square method says whenever you have a quadratic equation, if you put the constant on the right side, the coefficient of x simply determines the third term on the left side to become a complete square. If you divide the coefficient of x and add a square of that number to the both sides, then the left side becomes a complete square. So this is a good way, but you have to be careful. The right side needs to be a constant in these problems. Like for example, here the right side is 7. I have to move the 7 to the right side. So I have x squared plus 6x equals negative 7. Now let me just write it in this form. So I have x squared plus 6x equals negative 7. Now I'm going to add a number to both sides. And that will be determined by, as I said, the coefficient of x, which is 6. Now 6, you divide 6 by 2, you got 3, and you add both sides, just add both sides. 3 squared, which is 9. Don't forget. So I'm adding 9 to this side and 9 to this side. So nothing changes. So see, the left side, if you factor it, since this is 9, I got 3 and 3 as factors, and their sum is 6. So the left side becomes x plus 3 times x plus 3. You can check it. If you FOIL, you will really get that one. X squared, 3x, 3x, 6x plus 9. And the right side, so this one becomes x plus 3 squared. And the right side becomes 2. See, this is the way you completed the left side to a square. So from here we can just say x plus 3 equals minus plus square root of 2. By the squared property, I take the radical. So I subtract 3 from both sides. So these two cancel, and we get the final answer. X equals negative 3 minus plus square root of 2. So that's the solution set. And if you want to write the solution separately, you can write negative 3 minus square root of 2 and negative 3 plus square root of 2. That's how you write them separately. So that's one problem. Now I ask you to work on this problem. I give you the hint actually in here. So please pause the video and maybe for 2-3 minutes work on this problem, and then I'm going to go through the solution. So now for this problem, it's really the same thing, but you just divide everything by 2 to get rid of this 2 here, and then you apply the same argument that we did in there. It's going to be technically the same thing. Okay, that was completing the square method, and now the famous method, the quadratic formula. It says if you set one side equal to 0 for a quadratic equation, if you set one side equal to 0, then simply you can use the formula negative b minus plus square root of b squared minus 4ac to solve that equation. Like here, for example, one side equal to 0, a is simply 3, b is negative 6, and then c is 2. So let's use that one. X equals negative b minus plus square root of b squared minus 4ac divided by 2 times a. So negative b is negative 6. Here minus plus square root of b squared is negative 6 squared. It's going to be positive, so it's going to be minus 4 times 3 times 2, and then whole expression divided by 2 times 3. So you see this part will be simply 36 minus 24, right? So we get 12 in here. So we get square root of 12, but you may need to simplify that because this is like square root of 4 times 3. Square root of 4 is 2, so that's going to be 2 square root of 3. That'll be helpful. You'll see that in a minute. So we get 6 minus plus 2 square root of 3 divided by 6. See, you can divide each one by 6. They'll cancel. Now I have 6 over 6 minus plus 2 square root of 3 over 6. So 6 over 6 is 1 minus plus 2 over 6 is 1 over 3. So like these two will cancel. And I got 3 here. These two will cancel. I got 1 and 1. So that's 1. It's really clear. I just want to write that so it's clear. So it's going to be square root of 3 over 3. So these are the solutions for this problem. If you want to write them down separately, it's like 1 plus square root of 3 over 3 and 1 minus square root of 3 over 3. So we got two solutions. That's how you apply the quadratic formula. It's not really that bad. And this is kind of like the backup plan. If you couldn't factor it, for example, or if you couldn't do it by completing the square method, if the method is not specified, then you may use quadratic formula. It's a nice way. Now I have another problem here for you. Again, please try this problem for a couple of minutes and then I'll come back to the solution. So this is the problem. I actually give you some hint at the bottom, but yeah. So this is like the problem. This problem. So use quadratic formula. So yeah, for this problem, just something to just space because that's yeah. So if you look at this problem, you need to add 2 to both sides. So you have to set one side equal to 0. Don't forget that. That's something really important. Set right side. So set right side equal to 0. That's so important. Once you do that one, and then it's pretty much the same thing that we followed in the previous problem. So these are the problems about quadratic equations. Now I have 2 application problems for this section. Now the first example is you have a rectangular building lot. It's 8 feet longer than it is wide and has an area of 2,900 feet squared. Find the dimensions. So this is really, it's kind of like you have a rectangular lot, and the shorter side, if you call it like W, then this side will be simply W plus 8. And the area for this lot is given to be 2,900 square feet, and that's a quadratic equation. You'll see in a minute. Now area is simply, if you look at the area, this is W times W plus 8, and that's equal to 2,900. Now if you FOIL that, you had a problem like that in these notes. You FOIL and then you simply set one side equal to 0. So that becomes like W squared plus 8W, and that's equal to 2,900. Then you simply move that to the left side as a negative. So we have this equation, W squared plus 8 times W minus 2,900 equals 0. Folks, in here you may try to factor this, or you may use quadratic formula, because now you have calculators, you may use that. But really it's interesting, you can find factors in here whose sum will be negative 8. Look at that, 29 and 100. Of course I'm looking for something positive, so the negative will be the small one. Now this doesn't work, right? This doesn't work because if you add them you get 91. Now if you divide this one by 2, you get a 50. And if you multiply this one by 2, because you're dividing this by 2 means you need to multiply this one by 2, that will make it 58. And as I said, you have to put the negative to the small one because the sum should be positive 8. So this will be negative, and that works. See, we got 8. So this works. This doesn't work. See, our sum, like if you use the factors negative 50 and 58, their sum will be 8. So that works. Sum is 8. Sum is 8, so that works. So that's how you use factoring. If you're really stuck, please use quadratic formula. It will work. You can type it in a calculator. And from here now we have W minus 50 times W plus 58 equals 0. From here, W minus 50 equals 0, so W needs to be 50. Or from this side, W plus 58 equals 0. In other words, W equals negative 58. Now, as you see, W is the width, so it can't be negative because W is positive. That's the width. So the width needs to be 50 feet. So since the length is 8 feet longer, so that means the dimensions of this this lot is 50 feet by 58 feet. That should work. That's like the longer side and that's the shorter side. So I hope this problem is clear. And yeah, that was one application problem. I have one more for you to try. Now this problem, folks, you have a fish population model given as a quadratic equation, and in 2005, at the beginning of 2005, the population can be found by plugging in t equals 0. If you plug t equals 0, that's 60,000. Now it says after 2005, in another year, the population will also be the same as the initial value. When will that happen? So the initial population, as you see, if you plug in t equals 0, you got 60,000. That's the initial population. So how do you find this problem? Can you pause the video and just spend a couple minutes on that? Okay. Now, initial population is 60,000, so I need to set that equation equal to 60,000, folks. If you set it equal to 60,000, this 30 and 2,000, they will cancel. You know, like you can first divide both sides by 2,000. You got 30 and 30s will cancel. So you got t equals 0 or t equals 7. It's so beautiful because t equals 0 means the initial value. We already know it because we already know that the initial population of 60 is 60,000. It says after 7 years, 2012, the population will be same as the initial value, which is 60,000. Was a nice problem. And it is a second part. What do you think if they ask you at what date will all the fish in the lake have died? What do you think about this? Can you pause the video and write, just like try to solve this problem for a couple minutes? So now, yeah, now you can simply check that. You set it equal to 0, of course. I just put that in here. Died means f is 0. So I set it equal to 0. I have a quadratic equation, and you can always make this t squared coefficient positive by multiplying everything by -1. But folks, I want to say something. Like in these equations, I just picked up numbers that really factored, but all the time, if you get stuck, please don't forget you can use the quadratic formula. It should work. So I hope you're fine with this content. Thanks for watching. Bye.